Were they really heavy cakes and coffee or something? Well, no coffee maybe. Right. Okay, so my name is Richard Blewett, and this is Andy Clymer, who's doing my co-monkey for the session. We're going to be talking about the Reactive framework. So what we're going to talk about really is that, first of all, just talk about iteration in general, how the model works in .NET. I'm sure some of this will be very familiar to you, but we're going to talk about the fact there's two different modes, one of which is I knew Race has been around for a long time, and we'll talk about something that was introduced in version 4, the iObserver. We'll look at what the Reactive framework actually looks like, everything it's doing, and then we'll spend probably most of the talk talking about some example uses of it. This is not going to be every single thing you could possibly do with RX, because it is, as you'll see, it's a very, very flexible, and actually some quite impressive things you can do with relatively small amounts of code. More is really to give you a flavour of the sort of problems you can solve, which otherwise would actually be fairly complex to solve, actually fairly elegant solutions using RX. So, we kind of have this idea of iteration, of moving through a set of things one at a time. There's two models of iteration, I guess. There's pull-based and push-based. Pull-based is where the consumer is in control of the rate of iteration, saying, give me the next item, give me the next item, give me the next item. Push-based is if you like, the owner of the data is in control of the iteration, saying, here's an item, here's an item, here's an item. Okay? Now, you can model anything with either sort of a way of approaching the problem. So either direction you could do through pull or push. But some forms of data, some forms of sets and collections of things tend to lend themselves more towards one or the other. So if you have a list, as we'll see, you can do push-based iteration through it, although it's not the most natural way to actually consume a list of things that are already resident in memory. But sometimes we're working with things that aren't already resident in memory, that are appearing over time. And those things, at least for some of them, is a more natural way to handle this, is actually to be notified that they've arrived rather than be requesting them. Okay? So, pull-based iteration has had a formalized model inside the .NET framework since 1.0. Pair of interfaces, enumerable, enumerator. And lists and stacks and queues and all these standard collection types implement this sort of these pair of interfaces. So the idea is the consumer calls getEnumerator on enumerable, and enumerable returns back an iterator object which implements enumerator, and then the consumer says move next, move through, and has a current property to say give me the actual item we're currently on. Okay? So that's essentially the formalized model of how pull-based iteration has always worked. And it's not so much it's nice to have those pair of interfaces, but the fact that we can rely on the pair of interfaces allows us to weave services around those interfaces' existence that can then be applied to anything which implements this pattern. Okay? So, we've always had the ability to do push-based iteration since 1.0. We have delegates, and I can simply talk to someone who owns the data and say, here's a delegate. When you have an item, just call me back on the delegate. Okay? Completely, very straightforward way to deal with it. However, it's very ad hoc. There's no formal model that somehow we can weave a service around, because the signature of the delegate will differ depending on the form of data we're actually consuming. So, in .NET 4, they introduced a pair of interfaces. iObservable T and iObserver T. And the idea of this was the name come from a formalization of the observer pattern in .NET. So the subject, the thing that's going to have the interesting things with the data arriving, implements iObservable. And so anyone who's interested, the observer, who wants to receive notifications about the data, implements iObserver. Okay? And then the observer receives notifications, the next item arrives, on next is called. When there's no more data, on completed is called. And if there's some sort of issue, on error is called. And the observer talks to the subject and says, I'd like to be notified, and so calls subscribe passing its iObserver in. Notice there's no unsubscribe. Maybe we want to guess how we do unsubscription here. Because at some point you may want to say, I don't want these anymore. This is the audience participation. Yes, it returns a disposable. In other words, it returns a subscription object which you dispose when you do not want to receive any more subscriptions, okay, or any more notifications. The slightly odd thing about this was they implement this interfaces, or sort of they released the interface as part of the framework, but there were no implementations of them in .NET 4. It was just a pair of interfaces sort of hanging around with, sort of not attached to anything. But really, part of it was to say that here is the definition of what we're going to be using, and then we've seen over time things start getting released which actually have implementations with them. But we had the formal definition already available in the framework, so we didn't need another release of the framework to get the definition out there. Things could be released to the web, released to NuGet and stuff like that. Okay. Okay, so this is the model then. The consumer subscribes with its observer, and then as the subject gets various items arriving, or the next item is available, goes on next, on next, on next, until it's finished and goes on. Okay? And it turns out that anything that does pull-based iteration can actually be adapted to work with push-based iteration as well. Yeah, let's go and write some code. Okay, so we've got a list of people here. Can everyone see that at the back? No? Can you bump the font, Andy?
Shut off.
Should have got it earlier. Yeah, still 3 seats at the front, yeah. What size you want?
Go up to 14. Should be okay.
Can you read that?
Yeah.
Cool. Okay. So we've got a list of people. What we're going to do, we can obviously do a for each over this, but that's not the idea of what we're trying to achieve. So what we're going to do is we're going to turn this list into an observable. So can you create me a class called enumerable to observable adapter? Because this is an example of the adapter pattern, essentially. We've got an interface that looks like one thing, we want it to look like another thing, so we create a class that does the adapting for me. So it implements an observable of person, or T, I guess, here. And then, can you create a constructor which takes an enumerability, so the thing we're going to adapt. Yeah, variable.
You've got a different key map, haven't you?
Oh no!
You've done it deliberately, haven't you?
I don't think I'm going to be sharp as to make version, so I installed it again. You haven't. Look, you've also started the narrator now as well.
I just switched that off.
Well, you right click on it and say kill, and then it announces it's going away as well.
Oh, that is terrible. You've got to fix that for the rest of the week.
I'll fix that the next one, yeah. You can't remember how to do this now. Okay, so we've got the thing we're going to adapt. Now, because everything's already in memory, when someone subscribes, we don't really have another hook to start sending the data. So as they subscribe, we'll start basically sending back or running through the collection. Okay? So can you do a for each? And so T in adapt, and then we do observer dot on next, and passing the item. And when we're finished, we do all complete. Okay, now the final thing, we've got to return something. We've got to return an iDisposable. The idea of iDisposable is saying, I don't want to receive any more notifications, but we're kind of already done here. So in this case, we're just going to have a null implementation of iDisposable. Okay, right click, go to definition. Okay, so we've got a null implementation. So we've got something we can return. Obviously, it doesn't actually need to do anything. There's nothing, no work we've done in this case. So now what we can do, we can go back to our people, we can wrap this adapter around and get an observable person. The observable's not the stalker. The stalkee, the stalkee rather than the stalker.
Target, that's even better.
That's even more sinister.
New, go on.
New enumerable to observer adapter. Oh, people. Okay. Right then, so now we need to subscribe. So can you go and create a class called, well, stalker, I guess, that implements iObserver a person? And then in the method, just write out that, we've had the next item, write out the next item, then write out on complete. Don't worry about the error, because it's not going to happen.
Really?
Yeah, I'm convinced.
That's what we say. Okay, so, should I say value here?
Mm-hmm. Then, done. Okay, so we can now subscribe to the target, passing in the stalker. Okay, and this is the point we should see the iteration being performed, but this time in a push-based model rather than sort of more familiar pull-based model. Yeah, right? Okay. It's not very elegant to work with, though, is it? We have to sort of work quite hard. We have for each in as a way of wrapping up manipulation of our numerator. Here we don't really have it, so we're going to have to do a little bit of work to maybe give ourselves a bit more sort of a fluid, a bit more pleasant API to work with. So I guess the first thing we should do is say, well, at the moment, we have to roll a custom observer every single time. And in fact, we could do something reasonably similar, is if we just gave the opportunity for people to provide, here's a delegate I'd like you to invoke when you have a particular, when what next happens, for example. So can you create a class called delegating observer, which implements T, which implements iObserver of T. So what we need to pass in here, we need something that can take, as I say, completed, something that can take an exception, and something that can take a T, particularly so. So on next, action on completed, no, it's just not completed, and action of exception, but on error. Okay, and then store those somewhere. Without being able to resharpen. Let's see, when he has a resharpen, he has it set up completely differently than how I do. So it's payback already by forcing him not to be able to use it at all. Okay, so it's just an action there, yeah?
Oh, yeah, that's fine.
And then action exception on error. Okay, so now, rather than having to implement, they create one of these and pass in the delegates. But actually, sometimes you don't really care about maybe errors, or you don't care about completion. So we give a couple of overloaded, create a couple of overloaded constructors. So it takes on next and on completed. Just hands off the other one, and then one that just takes on next. And then we'll just do E goes to. And then finally, one for just on next. So essentially, pretty much any sort of combination we're interested in, we only have to pass the necessary. Okay, get rid of the comma. Okay.
Oh, yes.
Okay. And now what we do is on completed, we call on completed. And on next, we call on next. And on I know we should probably check to see what they're null. It's a demo. An error passing the error. And then finally on next pass the value. Okay. So this should make our code a little bit simpler now. Rather than having to create that, we'll just basically do target.subscribe and then new delegating observer. What's the person? Comes to right line. Okay, what should do. And this time we run off so we get a complete notification, but we also we're interesting. So that makes it a bit neater to deal with. So the other thing you can do, and obviously having to actually create this enumerable to observable is a bit sort of in your face. So if we get create a static class, we'll do a couple of extension methods. Okay, so I guess the first one we should have is returns an observability. And put it to observable. And let's do this enumerable. And essentially, so it gives us an easy way to do the adapting through an extension method. Yeah, enumerable thread. Okay, let's return new enumerable to observable adapter of items. Okay, so now we should be able to go up and change, or go down, sorry, into main.
Do you remember what I think you went to?
No, we'll come back. So we just change the code in main to get rid of the explicit creation of the enumerable to observable adapter. And now we can just do, just go to do target dot, I'm going to do people, get rid of that, comment it out, comment it out. Comment the line.
I know.
Nothing was happening. Okay, and so instead of target, do people dot to observable. Instead of target.
Yeah.
Yeah, people, parentheses. And then get rid of target.
Oh, I see. Okay, I get where you're going. All right. You didn't say.
Well, I was saying instead of target, there's only one word target on the screen.
It was above.
Right then. Okay, so makes it a bit neater. But this bit here doing new delegating observer, again itself is a bit awkward to deal with. So we've created and have another couple of extensions. Okay, so we'll just do the one, just for the sake of brevity. So what I want to do is it returns iDisposable, and we'll do call it subscribe. And it will extend iObservable with T, so subscribe with T. And then do items, something like that. And then do pass an action of T on next. Okay? And now what we do is we do items dot subscribe, and then in there do new delegating observer, and just pass it on next. And have to return that, yeah. Return the result. Okay. What's it like about that? Yeah, sorry, that's right. Okay, so now we're going down to main, and hopefully now it's all fairly neat to do. So just subscribe and just passing console right eye. and run that. So with a little bit of work, a little bit of infrastructure around it, we can make it very, very simple to wire up the sort of infrastructure around iObservable and iObserver. Okay? And this is basically the cycle of what RX does. Okay? So RX does all this stuff we've just done. So it basically wraps up and makes it very, very simple to work with iObservables. And if it stopped there, it wouldn't be that interesting. You know, the exercising, I can write generic code and stuff like that, but it turns out not only have they done, created a simple way of dealing with it, they've actually built a whole infrastructure of functionality and services around the set of interfaces. Okay, let's go back to slide. Okay, so the Reactive framework was originally a Dev Labs project, so sort of a playground where people experiment with stuff while they see what the take-up is. I think it's very early origins as a testing framework for Silverlight, I think. But it finally came out of Dev Labs and was released in this version of .NET 3.5, 4, 4.5. Silverlight is one for Microsoft Surface, a version of the Xbox, there's a version of JavaScript, it's just been ported to Java. It's become actually quite a widespread way of tackling issues which are based around observation as opposed to this sort of pull-based iteration. Okay. So ships in 4 assemblies, it's on NuGet, but 4 core assemblies. There's Reactive.core, which has all the main primitives that it uses. It has the interfaces, which is all the main abstractions that it uses. It has all platform services, which essentially give us sort of infrastructure about interactive tasks and various other bits and pieces. And then it also, as we'll see, has an implementation of link over iObservable as well. Okay, so as we just saw, if we have a bit of infrastructure support, working with iObservable is relatively straightforward and can be fairly neat. And this is one of the things RS gives us, but it gives us far, far more than that as well. So, it's really suited to doing asynchronous things, okay? Working with asynchronous things. So rather than everything being resident in memory, it's not a very interesting use of it to wrap up an IU rule, frankly. The stuff's already there in memory. Why wouldn't we use pull-based iteration for this? Okay? However, when we have asynchronous things become a bit more interesting. That there's sort of over a period of time, things are happening that we don't have to sit there and block and wait for. We just get notified when they occur through some mechanism of, well, in this case, on next being called. So obviously one observable thing we can talk about is tasks. Introduced in .NET 4, a new threading API came with .NET 4 byproduct of parallel framework extensions. And there's a static class in RX called observable, and has a method called start, which essentially we give it an action delegate, and it fires it. Now, it's an action delegate. Action doesn't return anything, obviously. So the observable, we have to come up with some arbitrary thing to use as T. Okay, and they call this unit, which someone's taken from Scala originally saw the concept of a type of unit. It's close to get to void, basically, but we can't obviously do observable and void. And then when we subscribe, we get on next when it finishes, and we get on completed when it finishes. So even though it works as an asynchronous model, it's a slightly odd thing to use because there's only one thing ever going to arrive, which is your on next in terms of the items. So it works. It is one way of composing sort of asynchrony. But it isn't the most interesting thing you can do with it. One thing that's probably more interesting is the idea to model event streams. And these might be UI events, they might be events coming in from a file system watcher, they might be events coming in from any arbitrary source like complex event processing or stream insight, whatever you call, firing interesting events from a stream of data that you basically put a subscription into. So there's a number of sort of event streams that we might want to work with. If you got a sensor that's firing sort of information back to you, all these sorts of things, trying to deal with data that's coming in completely asynchronously. We want to have some, hopefully, fairly elegant way of dealing with it. So Andy, there's a project called RX Events, I think. It's not a very interesting UI, I have to say. Just run it. As you can see, it's not a very interesting UI. It's one big text block. Okay, one big text block sitting there. What I want to do is write some code around my observable, which basically allows me to say where the x coordinate is on the for the mouse as we mouse over it. Okay. So on the observable class, there's a from event pattern method. And the from event pattern says, for some kind of event, start generating me a stream observable stream, essentially, rather than just a standard sort of event handler. So from event pattern, not event, yeah, from event pattern. Okay, and then we say what's going to be generating the events, and then which event we're interested in. Mouse move. Okay, then what we're going to do is dot subscribe. And then so we're going to get an event pattern item. So EP goes to EP dot. Now notice we have the two things you normally get from an event. The sender.
Just think about being around.
That's very good. I wasn't expecting it. Shocking. We have the sender and we get the event args. Okay? This is a mouse event args because we told it from event pattern mouse event args. And so what we can do is event args dot get position, and then you have to say what you want the position relative to, so this. And what we're going to do is then do the text block, which is, it's called my text. Text equals position dot x dot t-string. What's it running about? Oh, it's gone. Okay, so run that. Now as Andy mouse over the window, it'll be recording the exposition. So essentially we have the declarative way of stating what we want. Now, of course, we could have easily done this from an event handler as well. I'm not pretending you could never solve this problem any other way. Yeah, of course you can. But, as you can see, it actually gives us a declarative way of stating this is what our intent is. Okay, now, because we have a standard way of expressing push-based iteration, observable, it means we can start not only giving ourselves a bit of infrastructure to make it easier to work with, we can start layering in services over the top. Well, those services is link. Okay? So, where? Can you do a let above it, actually? We'll grab the position because we want to use it in two places. So, do a... Yeah, use proper link. Okay, so do... Well, you want to bracket around the whole from. So from EP in, and then observable from event pattern. Okay, and then go on to the next line where let x equals EP dot event args dot get position this x dot toString. Oh, no, I don't think you're right. So where x is greater than 300, select x dot toString, and then we can just subscribe, and s goes to string now. And s goes to my text dot text equals s. Okay. So run that. And now we'll only get the extra now as we go to 300.
Excuse me?
Yeah.
Can you just make sure that the code's going on the top of the screen?
Yeah, sorry, yeah. So, it's good.
Right.
So say when you can see.
A bit there.
Okay?
Okay.
There and above we're going to go.
Please.
Yeah, no problem. Okay, so you can see now, we have a way of saying, I can do conditional, I can potentially do ordering of events. Like basically, I have now a standard link implementation over the top of this, which gets us to introduce quite a powerful model. But they didn't just stop at link. There was a large number of extra things that don't exist in things. They started to introduce as well. Things that actually started to have quite so be able to solve some quite complex problems in very, very elegant ways. Let's go back to slides. Okay. So, we have a link. It gives a reasonably straightforward model to start filtering, so we only see the events we're actually interested in rather than having to filter inside a method. We can also compose them. We'll see this in a minute in another form, but essentially, if we have a couple of observables, then if we do select many, essentially, I'm sorry, I can't make the slide go up, but there's two froms down here. Okay. So essentially, we do like a link select many, then what we're saying.
It's okay, I can say it.
Then what we're essentially saying is return something when something's available in both of these observables. Okay? Okay, so here we've got two tasks running. We're basically saying when both tasks complete, then project out the results, because these are both tasks of T rather than task. Saying basically project out the results and in this case adding the two results together. Okay? So we can compose observables together, so we're interested in not just one single stream of events, but a composite of sets of events happening together. Okay, now, sometimes the fact the event happens isn't the interesting thing. It's the events combined with something else, maybe a second one of those events, within a certain time frame. Andy, you press the shift key 6 times. 5. Okay. So, what's that?
Annoying.
This is part of the accessibility support in Windows. Yeah? If you press the shift key 5 times within a certain time frame, then it will say what the assumption is you want the ability to be able to turn on. When you press the shift key, it doesn't come sort of unpressed until you press another key. So someone who can maybe only use one hand or something like that for typing can use the shift key in some way. Okay? So we're going to try and implement something similar. So, you will discover that Andy is useless at using a mouse during the course of this demo. Well, I know, okay. Actually, it might be better with a trackpad. It might work.
This is the first time I've ever done this with a trackpad.
It could be good, it could be worse. We have no idea. But it's not pretty with a mouse, let's put it that way. Okay, so he's not going to be asked to do anything very complex. It's just Andy might just doesn't work very well, it appears. Okay, come on in. Let's get to the project, the big red button. Now, it doesn't really do much at the moment. Just run it and don't put the mouse over the window. Okay. It's a big red button, as he likes to prove out. As soon as you put the mouse over it, isn't a big red button, but it doesn't do anything at the moment. So what we're going to do is we're going to, first of all, start recording the time interval between clicks. Okay? So let's go into the main window.cs. So we want observable.from event pattern of rooted event args. And again, it's this. It's on. Let's click. And then we want to do dot time interval. At this point, it's going to start, instead of giving us event patterns, it's going to give us a time interval between event patterns. Okay. So dot subscribe, and then can you do EP goes to, what's TI really, it's time interval. We'll do, I think the button's called the big red sexy button if I remember rightly. Dot tech content, not Windows forms anymore. Dot value. Dot toString. Okay. Value? Value is the event pattern bit. Yeah. Okay, run it. What have you done?
Then you've got to click on this.
Oh, sorry, that's the button, isn't it? Okay, try that. Okay, so now as Andy clicks, we'll start getting the time interval between clicks. No? I thought you were doing it, wasn't it? Okay. So, very easy to do. You don't get me 10 a second.
10 in a second now.
It's like track and field. Okay, so we've got the ability to record time intervals, but we don't really care about the time interval between each click. It's a set of clicks we're interested in. We don't want it to, like, if you press it twice quickly, then that pops up, because that would be extremely annoying if that was what's happening. So we want to do 5 clicks, okay? So we don't want to do the time interval of single clicks, we want to do the time interval of 5 clicks at a time. So what we can do here, instead of just saying throw each event out, is buffer 5 up and then give us the event for each 5. Okay? So we buffer for 5. Okay? So now we're going to record the time interval for 5 clicks. So what we want to do now is say if the interval is less than, so, well, what do you think, Andy? Can you do 2 seconds?
Which one?
Okay, 2 seconds. Then change the content to sticky clicks on. Okay, else. Well, you're going to record the time interval. See how far it was out. Okay, let's run that. Yep. So,
5 clicks.
5 clicks outside of 2 seconds. Okay, obviously not sticky clicks. 5 clicks within 2 seconds. That's 3 seconds.
Oh, yeah.
Yes! Okay, so you can see, we're starting to solve problems now, fairly simply, which actually would be a bit harder to deal with. Not impossible, but think about the sort of code you'd have to write to solve the same problem without RX. It becomes a little bit sort of like pieces all over the place with setting up timers and stuff like that. Okay, we'll come back to here in a minute. Let's go back to the slides. Okay, so we can do buffering. Okay, we can buffer for a number of events. Now, sometimes it isn't really what we want to do, though. Andy, can you go? There's another project called buffering. Sometimes we're working with event streams which are very, very dense. Okay? So asynchronous sets of event streams that are flying in, and we somehow are trying to show these are happening on the UI. So we have a large number of high volume trades, for example, or sensor data or piling in, something like that. Okay. Now, here's some code that essentially does this. We have a generator, we're using pull-based iteration, pull the events off, because this generates the data. We're trying to consume them as fast as possible, and as we get the item, we post it onto the UI threads, we can update the UI, recounting the number of ones that these are happening. Okay? So, let's run the code. No, just run it. Okay, now, what we have, when we click the button, then that's going to start counting up all the events that are taking place. So, click the button, and then move. Anyone know what happens? Well, we're certainly, the events are being generated asynchronously. Yeah. But if we go and look at the generate data method, notice that the events happen incredibly quickly. Okay. The problem is then that we're basically putting Windows messages on the Windows message queue of the UI thread, but there's so many of them saturating it. The actual interaction with the UI is getting lost in the noise. Okay? So the UI just stops responding. So somehow, instead of dealing with this massively dense event stream, we want to buffer them up to make sure that we only push them to the UI thread in a reasonable time period, okay? Something the UI thread can deal with. So, instead of this then, can we comment that out? Yeah, for each. And what we're going to do, we're going to turn this into an observable. So, generate data. Can you do this pirate screen? Or general transform? Okay, so generate data. No, it's dot to observable. Okay, then we'll do dot buffer. Now we don't really want to account those. The problem is, obviously, if we say, I don't know, 2,000, and we only happen to get 1,198, and then the events stop for a period. We actually want them, a time-based buffering rather than count-based buffering. Fortunately, the buffer method can take a time span as well. So time span dot from milliseconds, and let's punch out every 100 milliseconds. Yeah. Okay. And then what that does now, instead of giving me an observable stream of the actual items, it gives me an observable stream of lists of items. Okay, so I get to see each one that's happened within that buffered time frame. So, items goes to, and then we're going to have to do context.post, so use the synchronization context, push it to the UI thread, and then we'll do combi.value plus equals items.count. Yes. Okay, so we run this now. Oh, it did eventually get to the UI thread. It's actually died though. I think we might still be trying to. Oh, no, that's cool. Right, let's run it. And now, click it, and we should be able to start moving the window around. Okay? So we're starting to see actually this is quite a difficult problem to solve if you're writing it yourself in any sort of reasonably elegant way. And it's 6-7 lines of code. Yeah. And it's also declarative. It's not lots of bits of code all imperative trying to work out what it's doing. It's a reasonably clean way of describing, I want to basically take this set of data, make it observable, buffer it over a certain amount of time, then this is what I want to do when I get the items. Yeah. It's a declarative approach to stating your intent. Okay, let's go back to the slide. I'll kill that yet. Okay, so that's buffering. Sometimes you don't care about the actual items themselves, the exact each individual item of data. We're looking for trends. Okay, so this is where sampling comes in. Say that I don't want to have to process every single item of data. Just drop into the event stream that's flying past and pull items out. So I'm looking for trends that are happening within that event stream. Okay? So we have the ability to do sampling. This is another project in here, and what this does is essentially one of a temperature sensor, so say a data center or something. So it's sampling. Okay, so at the moment we're doing, we're saying buffer for 5 seconds all the sensor data that's coming through, and then we'll look at each of the items and say, have all the items now reached a certain threshold, 24 degrees in this case, and if they have, then we're going to start cooling. Okay? So, do you want to run that? So after 5 seconds, we'll find out how many items we processed and whether we were beyond that value. So, we're in tolerance currently, because not all of the items were outside of it, and now we're starting to cool. And we're processing 7 million pieces of data. Now we've got a very cheap thing going on, each item of data. What happens if the processing of that items of data was more expensive? This would be a brutal way of having to look at every single piece of data when we only really care about the general trend. So let's kill that. Okay, so what I want to do then is, instead of buffering the entire stream for 5 seconds, I want to sample the stream and just buffer the sample. Okay? So can you sample new time span from milliseconds, 100. So essentially, we're going to say every 100 milliseconds, just grab me a value about its event stream and buffer those for me. Okay? So run that. So at this point, instead of having to deal with 7 million items of data, we're doing 45. Okay? We're still getting the same kind of results we're interested in because we're only interested in the trend base. Okay? So again, this is non-trivial stuff to write yourself, at least in as few lines of code and as declaratively as this. They kill that. Right, let's get back to the slides. Now, that windowing was a huge reaction from downstairs, and that sort of fell over with shock. You see, let's go back to the big excessive button. The problem is that this is a terrible way to solve this problem currently. So, can you? Okay, open up main. And you'll see what the problem is with this approach. On the code, Andy. Okay, click twice. And now click 5 times very quickly. every time. Kill that, restart it. Okay, running. Click twice. Now click 5 times very quickly. Okay. So in theory, that should have triggered the functionality. Really, it's not like that and now every time Andy presses 5 times, do another 5. We're never actually going to hit it now, unless Andy does 7. So, or 8 or 9. Yeah. But see, the problem here is that we're basically saying the screen, I want 5, each subsequent 5, rather than if any 5 JSON clicks happen within that time frame, that's what I care about. So really what we want to do, instead of sort of buffering in the screen set of 5, I want a moving window of 5. Okay, and saying if there's any of these windows contain 5 within a certain time frame, that's what I identify significant. Okay, coming up now. It's a little bit more complex. You can imagine some more complex problem we're trying to solve. But hopefully you'll see this is still.
The whole lot coming down.
Pardon?
The whole lot.
Oh, and the whole lot comes down. We can't do it quite that straightforward. Okay, so I guess we still want the first 2 lines. It's still the same event stream we're interested in. Yeah. So.
On the bottom bit.
No. Just yeah. Go
No.
Yeah. We'll need that middle bit eventually. Okay. So what we want to do then here is say. This event stream, I don't want to look at the event stream in sets of 5. What I want to do is have a set of 5 events in a series of windows. Okay? Each window being 5 events long, and each one being 1 event further across. Okay? So a sliding window just separated by 1. So what we get to do in here is a whole bunch of overloads of this. Just go through the overloads. It's just two integers. Okay, this one. So it says count and skip. How many we're interested in, and how many want to skip from the previous window. Okay? So 5,1 will give us 5 events, but skipping 1 for each window, so we'll get the sliding window we're moving across. Now, can you just show us what that returns? Okay, what this returns is an iObservable of iObservables. So what it's giving us, it says, here's a 5 set of event stream that you can subscribe to separately. Okay? So what we need to do is do .subscribe. Okay, so this is going to give us the window now. So window goes to, W goes to. So this is another observable. So can you do w.subscribe? No, sorry, w.buffer.subscribe. We're going to buffer the 5 events that come up in here. Yeah, it's 5. And then we want to do dot subscribe, dot time interval after buffer. So we want to record, here's the 5, here's the time interval they took, and then essentially we want the code from below now. So TI goes to semicolon at the end. Okay, so go back up, just walk through the code again what we do. So for a series of click events, generate me a series of windows overlapped by 1. So we get every single 5 clicks in a separate group. Okay? So then this is going to return me a stream of these windows. So for each window, take all 5 events on it, work out how long they took, okay? And then based on that, we're now looking for things happening within 2 seconds. Are you sure you want to make it 3-ended?
Yes.
Or 6? Okay, 5, okay? Right, in 5 seconds, we've got to do 5 clicks.
You can do it.
Well, we should be able to, whether you can limit yourself to 5 clicks is more of the issue. But with more time, you won't panic quite so much. You do panic when you have to do a lot of clicks very quickly. Okay, so let's run this. Okay, so 2 clicks slowly. Okay, now wait. Okay, 5 clicks within 5 seconds now. Can you get rid of where we're writing out the interval.toString? Because that is just going to, it's doing a window each time every time we get over 5 now. Okay, 2 clicks. Can you do 5 reasonably quickly? Again? Or 6?
You did 5, didn't I?
I don't know, maybe one didn't take. I don't know. Yeah. Don't really hit that hard, because it might have to. Okay, but the point is we use a sliding window. It doesn't matter if there are some that are earlier, that are slower, we can ignore those because we're only interested in those events happening as a group within a certain time frame using a sliding window to do it. And you imagine trying to do that sort of thing, yourself, imperative code, you can get some very, very complex looking code to do that. And I know this isn't completely straightforward, but it's also not that complex for the sort of functionality we can achieve. Right. What more demo I want to talk about? So we've been doing this project with a video company where we do video kiosks, and so they're touch-based screens, okay? And so people can go up to them, they can do browsing, and on the monitors we've been using in the UK, gestures-based browsing, scrolling up is working very nicely. The monitors they decided to use in the US, the US-based company, doesn't support a scrolling gesture, or at least dealing with the drivers that are currently installed. So we're trying to work out how on earth to do this by code as opposed to needing driver support. So we thought that possibly we could do this via RX. It seemed to be a set of events we're composing. So what we're going to do is we're going to try and introduce scroll up and scroll down gestures. So there's an RX gestures now. Now I've got a little helper here, as we'll be using in a minute, but we'll come back to that in a minute. I'll talk about that in a minute. We're going to try a couple of different approaches to solving the problem. We'll see there's things that RX can do that may or may not be appropriate to this problem. Okay? That may not give us exactly what we want. So the first thing we're going to try and do is, can you create me an observable stream of mouse down events? So obviously you've got to click the mouse down, got to scroll. So it's click, scroll, release. Yeah. So mouse move, mouse bed arms, mouse not.
Mouse.
Yeah.
On this, yeah?
This, yes.
Sure.
Yep, yes, this. And then comma, mouse down. Okay, and can you store that somewhere? Yeah. I want that observable stored. No, just in another variable. Mouse downs. Okay. Then can you create another observable for mouse ups? So essentially, we need a mouse down and a mouse up, yeah. And what we want to work out is where, so where they were, and whether we had moved down or moved up, yeah. So, can you do from MD in mouse downs, MD, then from MU in mouse ups, or multi-binding. Okay, then what we're going to do is select can you create me a class that has actually no, I don't think it is. Yes, so I want a class that essentially has a X travel and Y travel. Travel.
That's double?
Yeah, the doubles are there, yeah. Okay. So when we select out, what we want to do is select out a new traveller. And then we want to do X equals MD. Oh, can you do a couple of? So want to let MDX. Actually, no, just do MDP for the mouse down point. Yeah, mouse down position equals MD dot event arcs, I think.
Sorry?
MD dot event arcs. They're event elements. No, that's at all. I'm running with scissors now. Okay, that's actually dot event arcs dot get position for this, and then let MU position. Okay, and then we'll select our traveller with X equals MU position minus X minus MD position minus X. MU position dot X. MU position let dot X minus MD position dot X. And same for Y's. Okay, so just try and work out where we've travelled between the two events. Yeah? Okay. And then what I'm going to do is just do semicolon. And then we'll do query dot subscribe. Okay, so
Oh yes, thank you very much.
okay, so now we want to subscribe and say as the traveller comes in. So T goes to traveller goes in. Say if traveller.x, or traveller.y, I should say, traveller.y is greater than 0, then, so that means the up was higher than the down, so that's amount, so do this dot content equals, scroll down, else scroll up. Okay, let's try running that. It should work.
What do I do?
So you've got to go into the window, mouse down, put it down, mouse up. Okay, so that was like that. Is that the wrong way around?
Yeah. Right, it depends on him, right?
Yeah, let's scroll up, yeah. Put it down, see, yeah, okay. And then you should be able to do up and up to the bottom.
Scroll down.
Hmm?
Scroll
Oh yeah, no, the problem is.
Don't say me.
No, it's to get position. MD minus, yeah, that would do it, wouldn't it? Yeah, that's MD, yeah. Thank you. Okay.
Someone knows that. Oh, which one did you go?
So let's do down first. Do up first, and then do down. So, yeah, down. I don't know. They're both coming up with that. Well, we don't know actually. They might not be coming up with anything.
Well, look up with something. Right, then beds.
Yeah, so we don't know whether it's always coming up with someone else or just nothing else.
Well, let's comment that out.
Yeah.
Well, no, you've got an e-file, so it's going to be.
Okay, so it's going to scroll up. I have a feeling you put a breakpoint in yeah, there. Yeah, I know what's going on. Yeah, so either way, it doesn't matter. I'll just go to the code. Okay, the field travel away. Yeah, 0. See, the problem is, when we try to get a position, essentially the point we're doing the mouse is in the same position. Yeah, we need to do it at the point when the actual event occurs. So this doesn't quite give us what we need. It's getting there, but even though there's also another problem. Andy, can you just go, let's press F5, so we carry on. Can you sort of do a horizontal S kind of movement?
Horizontal S.
Like,
Oh, try this.
yeah.
Sine wave.
Okay, or cosine wave, either would do. But make sure that the end finishes above the. Start down the bottom and go like that. Yeah.
I said, Jimmy gesturing up.
Gesturing up, but going down halfway through. Yeah.
Down.
Yeah. And then go up. Yeah. So you end up. Yeah. You leave higher up. See, in this situation, even if the code was doing exactly what we wanted, we have a problem. This isn't really that gesture, is it? It's not a scroll gesture. We're doing something else here. Okay. So we don't just want to check that each item ends up sort of. We end up further down and further above. We've got to make sure that every single point along the way has gone in the same direction. So even if we were getting the right value out here, it's not actually doing what we wanted to do. It's not identifying a gesture. We need to do something else. So, can you, let's comment that one out. Just a query. Query in the subscription.
This bit.
Yeah, and subscription. Okay, so, or move it to another file, whatever. But it's only moves to another method. But the idea is that that isn't quite sophisticated enough to give us an actual gesture. That would just say, does the mouse end up in a different position from the side? Well, even that's not really working either. So, okay, so what we're going to do now is say, I want to buffer up all the x coordinates, all the coordinates, until we get the mouse up. Okay? So what we can do then is do mouse downs dot. So mouse down dot subscribe. And I want to look at the mouse moves now, because it's the actual individual mouse moves I actually care about, not the mouse up, mouse down particularly. The mouse down just starts it, the mouse up just finishes it, but it's the mouse moves is the important thing. So subscribe, so EP goes to, and then can you do observable, observable dot from event pattern. We're going to subscribe now. Once you've had the mouse down hand, we're going to subscribe to the mouse moves. Okay? Mouse event args, this comma mouse move. Now, I want to buffer them, but not for a number, because I don't know how long the gesture is going to be. I don't know how long it's going to take them, especially without me doing it. So I want to basically say, close the buffer off when this other observable has something in it. Okay? So I'm simply give it another observable, saying, okay, I want to buffer until we get mouse ups. Okay? So an item from the mouse ups observable means this buffer is finished now. Yeah, just do mouse ups. Okay, and now what we're going to do is get a stream of event args, event patterns. Okay, so dot subscribe. Okay, and then we'll do maps. That's moves these are. Okay, so what are you doing? Okay, so what we want to do then is take this set of mouse moves. Can you turn it into a do a var points equals moves dot select m goes to m dot get position. M dot event args on get position. Okay, and so we're basically putting out the points, and then scroll down. There's an extension method down here. You see, link doesn't have the ability to say, compare each two items and apply potentially a predicate to them. To say, oh, do all of these adjacent items match this predicate? So this is what this does basically. It's called adjacent match. So here's a source, and here's a function that says, take two items and return a Boolean. So do they match some expression I'm going to pass it? Okay? So, so essentially we get a numerator, we get the previous item, there's nothing in there, there's a problem, and then we just walk through saying move next, replace them, comparing the two. Okay, so if we find one that fails, we return immediately, otherwise it passes. Okay? So, can you get rid of the semicolon at the end of that line? Dot adjacent match. And then essentially we want to take P, N goes to the previous and next, goes to, let's say P dot Y is greater than N dot Y. In other words, going down. In that case, that will scroll down, yeah? Okay, so now do that returns a Boolean now, yeah? Point isn't points now, it's a Boolean. Okay. Yeah. So let's do if scroll down. Right, scroll down, and also do scroll up. If start content equals scroll down. Yeah, I'll just do scroll up.
That's not true. No, that's not true.
You've done S, then you get it.
Yeah, you just scroll up.
Do you do a separate test or a scroll up?
Of course we do, yeah, we do compare. Yeah, so test first scroll up here, right, absolutely. Yeah, so else if. Do adjacent match. So,
do that block.
oh, go after, yeah, sorry, I have to do the two lines, don't I? Wait.
No?
Yeah, that's fine. Okay, so else if you scroll up. red semicolon there,
Where?
where you have the.
Oh, yeah, yeah. Sharpen.
Oh, you're in debug mode, yeah. Okay, run that. Okay, so move around, do a gesture. I know what it is. It's on purpose. Anyone else wrong? Well, we've got all of the events that happen between the two. We're seeing every single one. Can you put a breakpoint in
Is it because you're getting
on the
position?
Boolean, the first Boolean expression?
Is it because you're getting the position too late?
Yeah, again, essentially we're saying, I've got all these moves, but then I'm saying, get the position now relative to this point. It's too late. We need to do it at the point when it actually occurs. So again, it's quite a neat trick not to buffer, but for this particular point, it isn't going to solve the problem. Okay? Really what we want to do is see each individual one, extract the point at there, store it somewhere, and then compare the whole lot at the end. Okay? So, nice try, not quite there still. So, let's tuck that lot away somewhere.
With it?
Yeah. So this time what we want to do is I want to take the event stream that's taking place. I don't want to buffer, but I want to keep on taking them until the mouse up occurs. Okay? So can you create me a list of points?
You're getting all these.
Yeah, just so, oh no, I want the observables still.
All these things.
Yeah. So can you create me a list of points called gesture points? So what we're going to do now then is, again, we're going to subscribe to the mouse down. So that's when everything starts. Okay, so see the first bit of the code below you can take. Yeah, so essentially we want to subscribe to the mouse up. So yeah, we obviously won't be buffering, but at least that part's the same. Okay. So what we want to do then, instead of buffering, just say, oh, well, this event stream continues until a mouse up appears. Okay? So can you do take until? So we can say essentially, this event stream happens until this other thing occurs. And it may be a time-based one, it may be a number, but we can also pass it in observable. So take until mouse ups. Okay? But this time we're seeing each event happen now, rather than just getting them all bundled up. So we can record the event each time. So this is just a move, goes to, and then just do gesture points dot add move dot event args dot get position this. Okay, so that's recorded everything now. The other thing we need to do is finally when the mouse up happens, the gesture points will be an interesting thing to look at. Oh, we better do this. The mouse down is interesting as well. We want to record where the mouse down occurs. So just before we set up the observable from event pattern mouse move, for the mouse move one, to enter the subscribe.
Alright.
Yeah, add the point where the mouse down occurs. Yeah.
Okay.
So gesture points. Dot add. EP goes to. Oh, sorry. So get the mouse down position as well. Okay, so finally, not only do we want to stop taking this particular stream on mouse up, but we also want to do something else when mouse up occurs as well. So can you go to, we're going to subscribe to mouse ups separately. Yeah, so mouse ups, scroll up, so we don't, that's cool. Subscribe. So as soon as we get one of these, then essentially the gestures are interesting. So now what we can do is go to gesture points. So bool, scroll up. So it's that stuff there. Yeah. Bool is scroll up equals gesture points dot JSON match, and it's p n goes to. So yeah. The previous is greater than the, that's previous is greater than for others now. scroll down. Too many parentheses. Scroll down. Let's grade it down. So, what logic you had before?
Mute the list.
Oh, well, yeah. Yeah, we've got to be, well, I know it's too clear.
Yeah.
Okay, and then we just want to test and see whether we're scrolling down doing now, which you've got the code there. Okay, so hopefully, this one is intended to work, so hopefully it will. So, the Vandy does a scroll down. Yeah, go up. Okay, can you do some sort of wavy line? Okay, so essentially, it's not trivial to do this, but it gives you a framework to be able to express what you're trying to achieve in a declarative way. So instead of having individually trying to work out an event handlers and trying to contextually remember where you are, we have all the code in one place that's describing our intent. It's a non-trivial thing we're trying to solve here, to actually introduce gestures into something which doesn't natively support them. Yeah? Okay, so if you can think about how to do the logic for that, go for it. Halfway through, have you reversed direction? No. Okay, so let's go back to the slides. The idea then is, once we have this formalized model for how we do push-based iteration, and we have the ability to adapt things into that world, whether it be tasks, enumerables, events, or things that very naturally fit there natively. So Andy's doing a talk on TPL data flow tomorrow. So this idea data flow blocks, they can be observables. Okay. Things like it says Stream Insight has natively got the support for creating observable streams of notifications. Anything that fits that model, once we have a standard pattern for dealing with it, we can layer in very, very rich services. The point about RX is not that it gives you things you could not solve any other way, but hopefully it gives you a far more elegant way of expressing what you're trying to achieve and solutions that are more understandable for people reading than necessarily the large amounts of code in different event handlers and stuff like that. Okay? So, I think that's it. Any questions? We've got about 5 minutes or so questions.
Are there code examples available?
Oh yeah, absolutely. Yeah, I'll zip this up and I'll push it up to. I'll tweet about it. Go to the first slide. Or the first slide. Okay, so I'll tweet about it. I'll use the DevWeek hashtag. So if you follow the DevWeek hashtag, that I think it just repeats pretty much everything that comes out on there. It will probably be on the DevWeek website as well, but also on rockstarknowledge.com for all the demos and slide decks from the talks as well.